We are going to discuss the quantum mechanics problems of GATE Physics 2021. This is 1 mark question, and in this problem we have been given a wave function, and question is asking to determine the unit vector for this unit vector representing the direction of propagation for this matter wave. Now psi we have been provided as a e की power I 4x plus 3y plus 5z minus 10 pi t. In general, matter wave is represented like a to the power I k dot r minus omega t. So if we compare both these wave functions, we get k dot r is equals to 4x plus 3y plus 5z, whereas omega is equals to 10 pi. Now r vector, we know it always represented like x of x plus y of y plus z of z. That means vector k is having a form k of x cap, 3 of y plus 5 of z cap. Now the unit vector corresponding to k would be vector k divided by mod of k, which means 4x cap plus 3y cap plus 5z cap divided by root over 4 square plus 3 square plus 5 square. That means 1 by 5 root 2 into 4x cap plus 3y cap plus 5z cap, which can be represented 4 by 5 root 2 x cap plus 3 by 5 root 2 y cap plus 1 by root 2 z cap, that is n cap. In this problem, we have been provided phi for h cross s is equals to h cross by 2. Now the question is asking to determine the probability of finding the particle in a state S6 h cross by 2. So for S6 plus h cross by 2, phi of h cross by 2 is having the wave function 1 by root 2 1, 1. And similarly Sx with minus h cross by 2, phi 2 having eigenvalue minus 2 would be having wave function 1 by root 2 1, 1 minus 1. Now we would be expressing wave function phi in terms of a of phi 1 plus b of phi 2. If we would do that like, then we would be having 2 plus I by 3 and 2 by 3 is equals to a 1 by root 2 1 by root 2 plus b 1 by root 2 minus 1 by root 2 is equals to a plus b root 2 into 2 plus I by 3 and a minus b is equals to 2 by 3 root. Now on adding, we would get a plus b is equals to root 2 into 2 plus I by 3 and a minus b is equals to 2 root 2 by at 3. If we add, we get 2a is equals to root 2 into 4 plus I by 3, or a is equals to 4 plus I by 3 root 2. Now probability of finding the particle the probability of finding the particle in state phi 1 is P of phi 1 would be phi 1 of phi mod square, which is equals to mod a square, which is equals to 4 plus I by 3 root 2 का mod square, that is equals to 17 by 18. So answer in this case would be option D. This is a problem related to perturbation, and we have to determine the first order correction of an energy eigenvalue from the given potential curve. Now whenever the potential is starting from the nodes, then in that situation we can determine its correction, first order correction in energy using area under the curve. So we can use this relation, first order correction in energy is given by area under this curve divided by length or base. ठीक है जी. Now since this is an equilateral triangle, so the area under the curve would be half height is this V0 and base is L divided by length is L, so we would be having V0 by 2. So the first order correction in energy for this curve is V0 by 2. That means option C is correct. We have been provided this wave function psi 2x. The question is asking the wave function psi x t0 will be orthogonal to the psi xt at time t equal to. So let us write it down. Psi. At psi x0 we would be having psi 2x plus psi 4x, and normalized wave function can we write it like psi x0 is nothing but 1 by root 2 of, here you would be having psi 2x plus psi 4x. Now psi xt would be equals to 1 by root 2 psi 2x e की power minus I to t by h cut plus psi 4x e की power minus I e की power 4t by h cut. Now since psi of x0 is orthogonal with psi of xt, that means 1 by 2 psi 2x e की power minus I e to t by h cut plus psi 4x to power minus I a4 t by h cut is equals to 0. That means e to the power minus I a2 t by h cut plus e to the power minus I e4 t by h cut is equals to 1 implies e to the power minus I e2 t by h cut equals to minus e to the power minus I e4 t by h cut or e to the power e4 minus e2 h cut into 2 is equals to minus 1. That means to the power I e4 minus e2 t by h cut equals to e to the power I pi. Comparing e4 minus e2 by h cut, t is equals to pi, like t is equals to pi h cross pi e4 minus e2. Now e4 would be for one dimension harmonic oscillator, e4 would be 4 plus 1 by 2 h cut omega and e2 would be 2 plus 1 by 2 h cut omega. That means 9 by 2 h cut omega. Here you would be having 5 by 2 h cut omega. So pi h cut divided by 9 by 2 h cut omega minus 5 by 2 h cut omega give us pi h cross by 2 h omega. And so result will be pi by 2 omega. And that option A would be correct for this problem. This problem is related to, we would be having it a potential u0 e to the power minus alpha r by r. Now there are two ways to solve it. One is rigorous, another is shortcut or approximation. Question is saying as alpha tends to 0. When alpha is tending to 0, that means my potential is of the form minus mu naught by r, mu 0 by r. When the potential is of the form of Coulombic potential mu of r, we know it from Rutherford scattering. My f of cross-sectional element sigma theta is proportional to cos x to the power 4 theta by 2. That means my f of theta scattering element is proportional to cos x square theta by 2, which can be said it is proportional to 1 by sin square theta by 2, and this q can be written as 2k sin theta by 2. So f of theta is inversely proportional to 1 by q square. So our answer for this question would be option A, 1 by q square. We don't need to do the proper integration. Now, if we want to solve this problem by integration method, proper method, we would be doing it like this one. In first Born approximation, f of theta would be minus 2 mu by h cross square q r v of r sin qr dr limit 0 to infinity. Now minus 2 mu 0 h square q 0 to infinity r here you would be having it minus mu minus u0 e to the power minus alpha r by r into sine qr dr. So the result will be 2 mu 0 u0 h square q 0 to infinity e to the power minus alpha r sine qr dr. The value of this integral from the question is q by alpha is 2 mu 0 u0 h square q into q divided by alpha square plus q square. So in the limit f of theta in the limit alpha tends to 0 is proportional to 2 mu 0 u0 h square q h square alpha square plus q square would reduce to 2 mu 0 or you can write in mu 0 u0 divided by h square q square. So f of theta is proportional to 1 by q square. In these questions, 3 bosonic particles are placed in one dimension, infinite potential well of which we have to determine the energy of the third excited state. Now, energy of the particle inside one dimension box would be pi square h square by 2ma square. So ground state energy would be pi square h square by 2ma square, and first excited state energy would be 2 square pi square h square by 2ma square. Now we will see the distribution of the particle in 3 states. Okay? Now let us show it. GS ground state, FES first excited state, SCS second excited state, and TES third excited state. This corresponds to n is equals to 1 and this corresponds to n is equals to 2. Now in the ground state, since the particle is boson, all the particle would be in n is equals to 1 state. In first excited state, 2 particles would be in n is equals to 1 state and another one is in n is equals to 2 state. In second excited state, 1 particle is in n is equals to 1 state, another is in n is equals to 2 state, and for third excited state, all the 3 particles would be in n is equals to 2 state. So the energy ET for the third excited state would be 2 square pi square h square by 2ma square plus 2 square pi square h square by 2ma square plus 2 into pi square h square by 2ma square. So the energy for third excited state would be 6 pi square h square by ma square. That means the value of x is 6 in this case. The question is saying it. We have a 2 nuclear system in spin singlet state. Now for singlet space S is equals to 0. The spin is represented in the Polish matrix sigma 1, sigma 2. We have to determine the value of sigma 1 dot sigma 2. For this state, now we know it. In general, S can be represented for 2 particles like S2. Now it can be written as sigma into H cross by 2 sigma 1 plus H cross by 2 sigma 2 implies sigma dot sigma 1 plus sigma 2. Now, if we take the dot product of sigma with sigma, we would be having it sigma 1 plus sigma 2 dot sigma 1 plus sigma 2 would give us sigma 1 square plus sigma 2 square plus 2 sigma 1 dot sigma 2. So the value of sigma 1 dot sigma 2 would be equals to 1 by 2 sigma square plus sigma 1 square, minus sigma 2 square. Now, sigma for singlet state is 0 as S is 0 implies sigma is equals to 0. Sigma 1 square would be 3 and sigma 2 square would be equals to 3. So our result would be 1 by 2 0 minus 3 is equals to minus 3. Now you might be asking why I have written it. Sigma 1 square can be written as sigma x1 square plus sigma y1 square plus sigma z1 square, which gives us value I plus I is equals to 3i or 3. Similarly, sigma 2 square would give us value 3. In this problem, normalize radial wave function for second excited state of hydrogen atom is given. The question is asking you the distance at which electron is likely to be found. We have to determine at what point probability density is maximum. So probability density is in general represented by mod psi, or here I would be simply writing it R of R into R square dr. That gives us 1 by 24 AQ into A square into R square e की power minus R by A into R square dr. So we would be having it 1 by 24 e की power 5 R की power 4 e की power minus R by A dr PR. So probability is given by P of R is equals to 1 by 24 a की power 5 की power 4 e की power minus R by A. Now del P of del R would be equals to 1 by 24 a to the power 5 del by del R की power 4 e की power minus R by A must be equals to 0 or 4r cube e की power minus R by A minus R की power 4 by A की power minus R by A is equals to 0 or R cube e की power minus R by A is equals to 4 minus R by A is equals to 0. Now this term e की power minus R by A cannot be equal to 0 as it would make psi is equals to 0. ठीक है, as psi is not equal to 0, that means 4 minus R by A is equals to 0 implies 4 by 4A. So the distance at which electron is mostly likely to be found is 4A. So here integer value is 4.